Hey everyone, just wanted to take a few minutes here and kind of run through a few things to help you with the lab field assignment. Now, there's two videos here, as it states in the instructions, that you need to view and briefly summarize what's in them. And the first one I'm just going to be doing here from my home office, and just want to run over some basic things, some tips to help you be successful, and some things, some tips, some suggestions as to how to identify and describe your rock and mineral samples. And then the second video is actually out in the field, where I will hopefully be able to show you some more real life examples, if you will, of actually being out there, and how you might approach particularly part two of this assignment, okay, when you're identifying various geological processes and features and so forth, but also with collecting your rock samples. So the first thing I just want to say is don't get too stressed out about this. Don't get too twisted up. Make sure you have fun with it. A lot of students actually enjoy this process. It's a little stressful for them at first, but they're able to bring their families out to join them, and you really get to spend some quality family time while having an excuse, so to speak, to go out and hike and explore areas and go camping and things. So take advantage of that. And the other thing that's really critical is to start early. Definitely start early. You know, as humans, we're procrastinators by nature, and that's certainly something that can be a problem. So don't wait. There's a required rough draft due a few weeks before the final draft, but don't wait until then to start thinking about this. Send me bits and pieces of what you're doing. You know, you're having trouble with a rock that you're trying to identify. You want to know if you're on the right track. Send it to me, whether it's February, March, April, whatever the case may be. Send me whatever, and I'll give you some feedback. Don't wait for just a rough draft. Okay? Questions, ask. Definitely don't guess. Okay? And be sure to review the examples that I posted at the end of the instructions of previous lab field assignments done by students to get a sense of the kinds of things I'm looking for, as they were all A or A minus type assignments. So be sure to review those. Okay. So again, have fun and ask for feedback, lots of feedback from me. So I want you to really grow and learn from the experience, and I'm here to guide you, but I want you to really kind of take the bull by the horns and kind of get after this, and really look at this in a critical way, and really hone in a bit on your observational skills and your ability to kind of synthesize things, put things together. So that being said, one of the things that once you collect your hand samples, okay, and primarily I want you to collect for your 5 rock and minerals that you have to identify, I want you to collect hand samples, okay, which means small samples you can collect in your hand, hence the term. And some areas that you might want to be going to do this assignment will be national parks or perhaps state parks. Yosemite is a great place. Kings Canyon, anything like that is a great place to go. Any place that's of a national park is great. Pinnacles National Park, I highly recommend that. It's less than 2 hours from Coalinga, and it's right on the San Andreas Fault, so it's a great place to go document your fault. There's lots of other great things that you can accomplish there. You can complete a lot of your assignment by going to Pinnacles. I highly recommend it. But the one thing I'm getting at here is do not collect samples at national parks. It's against the law to actually bring something out of the park and collect it. So there you cannot collect hand samples. You can take really good pictures of some of the large rock masses. I don't want you to do that for every sample, but for 1 or 2 samples you can do that. That's okay. Okay, but basically you're going to be bringing samples back with you to have time to really look at them, identify properties, characteristics, and so forth. Okay, and one of the first things you're going to want to do is you're going to want to clean them up. Okay, depending where you find them. If you find them in a stream bed, maybe they're pretty clean already, but definitely you want to scrub them up a little bit, let them dry out, and you'll definitely be able to see the rocks, see their characteristics, perhaps their mineralogy or their components, okay, that make up the rock, particularly in the sedimentary rock. If you have a clastic or detrital type of rock, you're going to have the little bits of mineral fragments in there. So if you clean it up, you better see this stuff much easier. And the other thing, if you happen to be lucky enough to find a rock with a fossil in it, you will want to, after cleaning it up, maybe take some clear nail polish and paint over that fossil. It really brings it out and separates it from the rest of the rock. So it makes it easy to observe and look at the characteristics of that particular fossil. Okay, so let's take a look at a couple of samples here. I've got a sample here of a mineral. Okay, and as you'll learn, or are learning, that minerals are different from rocks in that they are homogeneous. They are, no matter how you slice and dice this particular mineral, which happens to be halite, by the way. Actually, I take that back. This is actually calcite. My apologies. This is calcite. Very common mineral. Matter of fact, it comprises limestone. Calcite does. Limestone is almost entirely calcite. Okay, and no matter how you slice and dice this calcite, it is going to be comprised of the same elements. In this case, calcium and carbon. Okay, CaCO3 is the chemical formula for it, calcium carbonate. Okay, it's always going to be the same. Unlike a rock, which is an aggregate of at least one mineral, usually several minerals, and no matter when you slice and dice the rock, it's going to be the mineral makeup is going to be different. Okay, so, and by the way, a great way to test if you have calcite is to drop some sort of weak acid on it. Oftentimes in a lab situation you'll drop hydrochloric acid, but probably not having your hands on hydrochloric acid, you can also use vinegar. Vinegar will also react. And also the fact that calcite comprises limestone, you can also do the vinegar test to test for limestone as well. And also marble, which I have an example of here. It's kind of washed out in the light here. But marble also is comprised of limestone that has been metamorphosed, okay, changed by great heat and pressure. Okay, and it's not showing up so well. I'll bring it over here. Maybe it'll show up a little bit better. Not so good. It's too dark in here. But at any rate, you can also use the vinegar test to see if you have marble. Okay, and marble comes in all kinds of different colors as well. So white, pink, and so forth. But a metamorphic rock, marble. So you're going to want to look at these, and you want to try to identify, first of all, see if the rock seems to be crystalline, or if it seems to be made up of minerals, or if it's got rock fragments in it. Okay, to kind of give you a sense of what type of rock you might be dealing with. Okay, now, hey guys, a couple things I forgot. I apologize for the length of this, but there's just so many things to consider. One thing I did not make clear was with the vinegar test for calcite and for things that contain calcite like limestone and metamorphosed limestone, which would be marble, and so forth. Vinegar is a weak acid, and it's called acetic acid, and what happens when you apply this acid to the mineral calcite or something that contains calcite is it effervesces, it bubbles up. Okay, so if you get this effervescing, bubbling up when you apply some of the vinegar to your sample, then you know it contains calcite, whether it's the mineral calcite itself or the a rock that contains calcite. All right, that's it. Thanks. In this case, we have a rock that is clearly, you can see, comprised of several different minerals. In this case, it doesn't really show up very well here, but you have some sort of pinkish colored rocks. You have black, and you have a whitish or clear type of rock. So three very distinct minerals in this rock. Okay, and again, hence the difference between this and your calcite. Okay, homogeneous. How you slice and dice this. This is going to be all different combinations of these three different minerals when you cut it up. Okay, so what we have here is an igneous rock, granite. Okay, so you're going to want to look at this and identify those type of minerals. Okay, it's part of the mineralogy of the rocks. You want to do your best to pull out these different minerals and say, okay, well, we have orthoclase, and we also have hornblende, and we have which is the black. We have the orthoclase is the pinkish color mineral, and the clear is the quartz. Okay, you want to pull all these things out. You want to look at these properties. Now, in case, let's go back here again to the calcite. What are some of the features? What are some of the properties here? You know, how does this mineral break? In this case, this mineral has what's called cleavage. Okay, it breaks along these flat planes. How many directions? What's the color? There's all kinds of properties and characteristics that you can use to help you identify them. Okay, does it have an odor? Is it magnetic? All kinds of tests you can use. Okay, and then you have sedimentary rock here, which happens to have a nice fossil, a couple nice fossils in it actually. You can see one here, which is actually part of a trilobite, and then here you also have one. Again, if you remember, if you paint this with clear nail polish, this will really show up very nicely. This is part of what's called an orthocone cephalopod, Spirocerus, right here. So if you're lucky enough to find this, this is really cool. And you also know that this must be a sedimentary rock, okay? Because think about how fossils form, okay, or how fossils are preserved, should I say, and how rocks like igneous or metamorphic rocks form. Igneous rocks are molten material, so chances of them fossils preserving in rock that's been melted is not going to happen. Basically, metamorphic rocks, they're altered. They're rocks that are altered by great heat and pressure. So very, very unlikely that fossils preserve in metamorphic rocks. But sometimes they do under low-grade metamorphism. If you take a shale like this and you change it into slate, occasionally you'll get fossil preservation. But generally, if you have fossils like this, you're 99.5% sure that, or 99.9% probably sure that it's sedimentary. Okay, so these are the kind of things you're going to look at and observe. And again, you're going to want to have a hand lens, a good magnifying glass, and you can look at some of these features and see if there's little what are called clasts, which are little rock fragments which make up these clastic or detrital sedimentary rocks. So definitely have a good magnifying glass. Spend some time looking at these and trying to come up with the properties. There's many properties and characteristics. That's what I'm looking for. Okay, I'm looking for some detail in your descriptions. Okay, I want to know your methodology. I want to know how did you go about identifying these. Okay, what were your steps? That's what's important. You're not going to necessarily get everything right. I'm not so worried about the correct identifications as much as I am the process. Okay, you need to describe your process for me, and you need to give as much detail as possible for how you go about identifying your samples. Okay, and again, detail. Okay, I don't want to overdo it here with this, but you want to give me as much as you can um, with this. And if you get it wrong, it's still going to be a pretty good job because it's tough. It's going to be challenging for some of these rocks and minerals to identify them. Okay. All right. Well, that's it for this part. Again, questions, please ask. Send me stuff for me to look at. I'll give you my feedback, give you some help where I can. Again, the onus is on you. I want you to really embrace this and learn by doing this. But certainly, I'm here to guide you and help you. So, all right, look for the second video here attached. It's going to be from out in the field, where we'll actually be able to look at some actual situations out in the field that you might encounter. Even though I'm here on the East Coast, there's still some similarities, some generalities in the rock formations, and certainly in geological processes, no matter where you are, East Coast or West Coast. So, all right, questions ask, and have fun with this, guys. Hey guys, back again. Hopefully, I won't promise it'll be the last time, but again, I'm just really trying to make this helpful for you. The other thing I wanted to add here was again some additional locations where you can go, and really, guys, geology is all over the place, so you don't necessarily have to go very far to collect samples and to observe many of these processes and geological features. I will suggest a couple of really neat places, and I know some places that students have gone in the past several times over. I mentioned previously Pinnacles National Park. Again, 2 hours, under 2 hours away from Coalinga. A national park that is just tremendous. Very cool, right on the San Andreas. You can get a lot of your project done right there and really enjoy what the park has to offer, and try to connect with some of your classmates. You have to do this project on your own, as it is a big representation of your lab component here, your lab mastery of the class. But certainly carpool together, ride the Pinnacles together, or wherever. Definitely, I would recommend that if you can do that. A lot of people go to Yosemite National Park. Again, you can't collect anything here, but a great place to go. Also, Shaver Lake is a popular place. Pismo Beach, the Three Sisters, and let's see, Moonstone Beach is another place. Oh gosh, there's so many that are escaping me right now, but there's many places that you can go. And if you have questions about it, certainly ask me. But any place where you can collect samples, I mean, legally, don't get in trouble on private property. But other national parks, as I've said many times, don't collect there. Is good. So take the opportunity to get out and travel and look at some different areas. Maybe get your family out there with you and kind of enjoy doing some classwork while getting out and exploring the natural world with your family. So embrace that aspect of it, and don't dread it, but have fun with it. So, all right, I'm going to leave it at that point, and we'll talk to you later. Thanks.